Prototype pollution is a quite niche technique that a lot of bug bounty hunters do actually know about, but very few actually utilize it. That being said, it can be quite useful in specific scenarios, and as well as that, you can use it in both client-side and server-side attacks, which can make it pretty impactful. Today, I'm going to be covering over what prototype pollution is, and then I'm going to be covering a live example that you can follow along with me. So hopefully you can get the practical knowledge needed to start hunting for prototype pollution in your bug bounty targets. Right, so what is prototype pollution? Well, prototype pollution is not a vulnerability. It's not a vulnerability type, right? But it is a helpful gadget for finding other vulnerabilities, mostly cross-site scripting and cross-site request forgery. And it originates because of this weird inheritance in JavaScript. Inheritance is a thing in programming languages where basically one object or class inherits the properties of another one, usually some kind of like functions or values or like general properties. And it kind of originated from object-oriented programming, and I think Java is the programming language that really popularized it, with Java classes, and really inheritance is a very important part of those object-oriented programming languages like Java. And inheritance in JavaScript is also very important. However, it works very weirdly and quite differently to other programming languages, in that most programming languages have static inheritance. So the compiler will compile the code, and the inheritance will be basically baked into the actual program. And then once it's compiled, you can't modify the inheritance. It's just the way it is. However, in JavaScript, it doesn't work like that. Inheritance is actually dynamic rather than static. What that means is that you can change the inheritance of objects after you've compiled the code, which is, I've never seen that before in a programming language. It's a very interesting concept, and it can lead to a lot of cool things, but it can also lead to the vulnerabilities, which I'm going to talk about today. And inheritance is controlled with this property called object.prototype, and in general, this prototype object is what controls inheritance. Let's look at an example of that. We have this box class, right? This box class, and we have created it, right? And it has a constructor, just like any other programming languages. You can make a class, you can give it a constructor, and then you can define functions within that actual class. But what happens here is that this actually gets added to the object.prototype. That means that what we can do is we can call it later like this. I believe you can also call this value here, the this.value, you can also call that from the prototype. What it basically means is that we can just call box.getValue when we declare a new box class like so. That's pretty simple to understand, and most languages will allow you to do this. As well as that, there's default values that box inherits from the object type, which are some basic values that every object in JavaScript will have. And this is also pretty normal in most programming languages. Like if you have a string value, you'll be able to always convert that string to something else. That's very normal, and that's because string inherits from a type called string. Right, cool. So inheritance here, nothing usual. This is just pretty normal object-oriented stuff. But this is where it gets weird. Let's say we have this box class, right? We have just declared a new box. And then we call box.getValue, right? Same thing, we just get the value. What we can do though is then we can change the actual inheritance. So we can change what getValue does after we've declared the class, and we can set it to something else. So if we call the same line of code, we get a different function being called. And this is unique to JavaScript. I don't think you can do this in most other programming languages. Basically changing the actual value of the inheritance after we've kind of done it. And this will apply to all objects that we've created after we change the inheritance, right? So this box object is what's changed. What is super interesting as well is this applies to every object in JavaScript, not just this one we've created, but even the top level object type is affected by this. So we can change the inheritance of the object type, and then it will apply to every other descendant of it, even after the compilation has happened. So if we set something like object dot, so that's prototype dot test, like this, is equal to 1, then any object, including box, that we can type in here, if we said dot test, it would return a value of 1, which is pretty interesting because we've just done that after runtime. So that leads to a lot of cool things you can do, like changing these values after it happens, and it can lead to a lot of nice little features, but it can also lead to a vulnerability, right? If we were able to change some kind of type, some kind of like parameter from a class that's being used by the code, say this is client side, right? Then, like let's say this eval function, if object is like say this is box, right? Whatever, say this is like box.script, right? And box has a value called script in it. If we later on changed .script by going to object.prototype.script and we changed it to be something else, then we could overwrite this value that's being used by box, and then basically we could just run whatever code we wanted to if that was user controlled, right? That's something that can happen. As well as that, remember that in JavaScript, anything that looks like this with like the curly brackets and then has some kind of like value is considered an object. That means that it automatically inherits from the object type. But take this fetch command, right? And it uses this object here to pass in some kind of settings. In this case, we say mode is equal to course. Other values include like method, and for example, like body are things we can send over, right? If we modify the object to contain a type called method or a value called method, then what it would do is this would actually like invisibly pass in method into this fetch function, and we could define whatever method we wanted to, as well as whatever body we wanted to. Which is weird because as a developer, you didn't even include the method type. So where did that come from? Well, it came from the object. Because when fetch ran object.method, it will get whatever value we gave method. And that I think is super interesting and a vulnerability that you're going to see now in the live example. Right, this is a live example, and the goal will be to send a post message to users.php by sending a link to the victim utilizing parameters.html. Like imagine there's like a CSRF defense or something like that, and the CSRF token is automatically appended with like the fetch request the website is going to make. So if we just come here, it'll give me this request called found user, and that's sending a get request to users.php. So our goal is to change that get request to a post request using the technique I actually just talked about. Let's have a look at the code for this. Here, it's all included on the webpage, of course. You can have a look at it there, but I'm just going to have a look at this in this nicer format. You can see we have the function get users that's being called here with the location.ref, and then we have a fetch request being made without course. Nice. And then if the request has a found value in it, it's going to print found user, and if it's deleted my account, then it's going to print deleted. Okay, cool. Let's look at this get users function because this is where the actual vulnerability is going to lie. And what it's doing is it's going to find these kind of search parameter fields. One of them is names, fields, and value. So we can set like a user value for a field, whatever. This is kind of just mock functionality that I found online. And the interesting thing is this here, these square brackets, are the exact same in JavaScript as doing, say this is result, right? That's the exact same as doing dot and then name here, like whatever the name in there was, and then dot field, right? So there's no difference there. It's just that the square brackets can be modified at runtime, while the dot has to be constant. So that effectively does the same thing. And since name and field, you can see here, are user controlled because they just come from the search parameters, that can be user controlled by us, and the value is also user controlled. Okay, cool. If you see an issue here though, because every object, as I mentioned before, has the prototype property that we can modify. So if we do result dot, okay, maybe it won't show me this. Okay, over here, this is an object, right? Because it's square curly brackets. Okay, it's not going to show me it, but it has the property proto because that's what the inheritance is going to be, and this is currently just inheriting from the object. So basically, the main one. What we want to do is change it so that we can pollute the main prototype. So we can get the object value and then change its prototype. That's what we actually want. And that's going to be ideally what we want to do with this exploit. And the way we're going to do that is with this other object called proto, which is going to give us like the prototype object of the object itself, right? So it's gonna like kind of like go up the inheritance chain, right? And that's what's going to allow us to edit the prototype. So let's have a look at that, right? We're going to go here and we're going to say values. Just keep that maybe open here. I'll just move it to the left so I can actually see what stuff we're typing in. The first one is going to be names. So say we'll just say test for now. We'll just have a look at this. And then we'll say fields. And then we want to set the value for a field. So this isn't really going to do anything right now. But we'll just go in here. You can see it hasn't done the post request. But a useful thing to do here is to go into the console and see what's happening here. What we do want to change is we want to ideally change object.prototype.method. This is currently what we want to change. And currently it's undefined, so we don't want it to be undefined. We want it to be method, right? So what we need to do is we need to access field proto, which is going to give us the prototype of the object, and then set the field. In this case, you can see the field method, which is the one we want to change, to the value that we're looking at, which is going to be post. We want to send it to a post value. If we hit this, you can see invalid request method. Okay, sorry, this is supposed to be value. Value is equal to post. Yeah, okay. If we set it now, then you can see we have changed the fetch request to a post request just with the URL search parameters, which I think is very cool. And if we go into the console and we say print, you can see we've changed the object.prototype to be post. I wonder if you can actually access result. You can. I'm not sure if this will work. We'll say result. Okay, that will not allow us to access it. Either way, what happened was result, we accessed the prototype of result, which gave us the prototype of the object, which we applied the method to. And then, if you look further on in the code, this fetch used this little object here. This object inherited from the prototype of the main object, and since we edited the method of the object of prototype, it assumed that the method was in this object itself, and then it fetched using a post request instead of a get request. What we could also do is append a body to this or append any headers we wanted to, and presumably there's like a CSRF token here being used by the website to like validate if you're like submitting it or whatever, and it's using cookies. So that's how we were able to exploit this. Only slightly confusing. Basically, whenever you see something like this where it's like using these square brackets with a user controlled value, you can try prototype pollution. And what I would do is I would put the payload at the top of the page and then check whether the actual prototype got modified by just typing in object.prototype.whatever field you were modifying, right? I think you can even type in the whole prototype and it'll return like the whole object, right? So this is like the default basically object prototype. So every single object has access to these. And we notified it with this method is equal to post, as you can see on the top. So that's very cool. That's the first thing that you can do with this. And this is what happens when using these kind of parameters on top. The second, and I would probably say more common way that prototype pollution happens is with JSON. JSON is like a JavaScript representation of like objects, like a string version of it. and we're going to go and look at the source code as well. So similar thing happening, we're going to get the parameters from the URL search bar. This can happen from like a post request even or whatever, but in this case, it's just easier for me to code in the parameters. And then we're going to parse that parameter as JSON. This is okay, right? So we can parse our parameter as JSON, and even if there's a prototype object in there, that's fine because it'll be treated as its own like separate object. That's fine for now. The issue starts if we try and assign that object. If we try and use object.assign to basically merge these two things, right? What object.assign does is it kind of merges two objects together and assigns like each. So if we had like two objects and we had this object A is 1, right? And B is like 2. If we merged it with a second object, like C is 3, we would have an object like this. A is equal to 1, B is equal to 2, and C is equal to 3. So we would have this object coming out of it, right? And it also modifies existing values. So remember, like if we had like A is equal to 2, then A will be equal to 2 after we've modified it. So keep that in mind, right? And here, what we're doing is we're assigning the settings for the request using the JSON parameter. What we've blocked here using a defense is the method. So we don't want the user to be able to control the method. So we can go try that, right? Let's just go here and let's see. I think it's the parameter is called JSON. Okay, the parameter is called JSON. So we'll set the parameter to JSON to something like this, and we'll say method, which is, we'll say like post, right? So if we send the method post, you can see that nothing happened because it was blocked by the JavaScript because we have a method here. Okay, how else could we set the method? Well, if the method is being set, maybe the proto object is also being set, right? Thing is, if we're setting the prototype object, that means that we're setting the actual prototype to something else. So in this case, we're not going to be able to modify the object prototype, but we're going to be able to modify the prototype of this specific type and the specific object here. So if we, for example, decide to change the prototype of this object to method like this, and we say method is equal to post, that means that whatever object this is, it's going to stop inheriting from object. So all of those prototypes are going to be gone. And it's instead going to be inheriting from this new object that we just created, which is here. And this itself is going to inherit from the object prototype, which means that those methods will actually be back there like that. So we've kind of created like a new tree. We've just inserted like a middleman in between it, which is our object. So now let's see what happens. We inject it here, and you can see we have managed to delete the user's account. I think in this case, if we print settings here, okay, maybe not. Maybe it won't let me do that. See? Oh, yeah, it won't let me do that because it's in here. Let's say you print something like JSON instead then. If we say print JSON, JSON is here, and you can see this is the object that was basically converted by the JSON.parse function. And you can see everything here is safe. So the unsafe part was the object.assign. And in this case, that's what caused the vulnerability. Where instead of basically, actually maybe I'll show it to you in here. We'll say like console.log settings like this. So print that in there. Then we'll rerun the code, delete it, and you can see object and the prototype, which in this case has the method post, right? And the prototype inherits from itself from the object prototype. So you can see we've just created like a new tree and we've inserted whatever we want to here. So that's a phenomenal way in which we can edit the prototype of a specific object, which depending on how it's handled by the JavaScript might lead to a vulnerability or not. So this isn't like a guaranteed vulnerability, right? Prototype pollution is just a gadget to get us somewhere where we can get a vulnerability, but it's not necessarily a guaranteed one. For example, if this settings object didn't do anything, well then there's no vulnerability because it'll be cool. We can assign a prototype. However, we can't escalate it to assigning the object prototype and we can't like do anything with it. We can't add extra parameters or anything like that. So it's not going to lead to a vulnerability. In this case, it is because the settings object is being used kind of dangerously in this fetch function, and the check isn't that great. So that's what's going to lead to a vulnerability. It's good for bypassing these kind of weak defenses as well. So what are some defenses to prototype pollution? Well, one of them is by actually freezing the prototype. So object.freeze is a JavaScript function which prevents modifying a value. And in this case, if we freeze the object.prototype, then you can't insert any extra values into the prototype. So even if we wanted to inject this method is equal to post, it won't do anything because the prototype has been frozen. The issue is that this can break some libraries that actually use the object.prototype. So I don't know whether this is seen a lot, but if you run this after the library is loaded, it's okay. But if you load it before, it might break. So if we change this method to post and then we try to fetch this, then it would like still do a get request because this method doesn't exist, right? I can even show you that. We go here, defenses.html. We come here, see some are very blocked or something like that. Yeah, if we go now print out object.prototype.method and run it, you can see it's undefined, even though we've tried to set it in the code, but it hasn't worked. Okay. The second way that we can prevent prototype pollution on particularly sensitive requests might be to actually set the prototype to null. In this case, even if I, as an attacker, were able to inject some kind of value into the object prototype, it would actually not be inherited from by this particular object because we have set the prototype to be null. So in this case, there is no prototype at all, and there's no inheritance. So this object is just exactly as we see it because there's nothing else that will inherit from it. So let's just give that a try. Just see here, we see we have set the object.prototype.method. But let's say we copy this object here. Let me say console.log. We just log this entire object like so. Then we refresh it. You can see there's none of that prototype value you saw before, where I was able to expand it and see what the inheritance is. That's not here because there's no inheritance at all, and we've just basically gotten rid of the inheritance. So that's one way to defend against prototype pollution on particularly sensitive requests, but this isn't really a good idea, mainly because if the person can already inject into the object prototype, the chance they're going to be able to find a vulnerability is pretty high, and setting this proto on every single object could probably get pretty tedious, I imagine. So this is sort of a defense, but not really. So the main defense is just to prevent prototype pollution in the first place by basically just like not doing this. That's basically the main defense, to prevent it, or by locking the prototype. I did mention that this is both a client and server-side attack. And that is true, because if you're running Node.js, if you're using a JavaScript framework, Next.js, Node.js, Express.js, then this is still possible. All of these functions, like I think JSON.parse even, like they exist inside normal JavaScript. Especially like I think the object assign one in particular does exist as well. That means that this is still vulnerable to prototype pollution, and just because it's server-side doesn't mean that the inheritance is different. It's the exact same in server-side JavaScript. So all the same vulnerabilities apply. In the case of server-side JavaScript, it's a bit more severe. I think you can pretty much get like a guaranteed RCE if you're able to inject into this object.prototype method. I think in Node.js there's like a special function that does it. I'm not sure. You can go read into that a little bit yourself. However, I know that it's very serious. The only minus is that it's quite hard to find in a black box test. That's why prototype pollution in like a black box scenario tends to be seen more on client side rather than server side. However, you should know that both are possible, and if your target is using Node.js or a JavaScript framework, then you can absolutely look for prototype pollution as well. I hope you enjoyed this video covering prototype pollution, a pretty funny little gadget that you can use due to some of the quirks that arise in JavaScript inheritance. It's a particularly important skill if you're looking at code review in Node.js applications, or obviously if you're looking to escalate client-side attacks and get better at that. And speaking of that, actually, I'm going to be doing a lot more client-side stuff on the channel in the next coming of weeks. It's a skill that I'm working on because I think that it's where bug bounty is really headed, and it's also just fun. It's definitely fun because you can chain a lot of attacks and stuff like that. So I do also enjoy looking at it, and I hope you will enjoy it as well. If you have anything that you want me to look at from client-side attacks, then be sure to leave a comment below in order to tell me what you want me to focus on and maybe what you don't want to look at as well. And yeah, that's it from me. Thanks for watching and happy hunting. By the way, no pressure, but if you did enjoy the labs that I have throughout this video, then you might consider checking out the labs in the description, which are 12 hands-on practical labs that you can find online, just like the ones that I showcased in this video.